All right, so today we're going to talk about graphing a quadratic function. Awesome, so the first thing we need to do so we can graph it is figure out what in the world's a quadratic function. Well, here it is right here. There are two forms for a quadratic function. This top form is called standard form. So that's what we're used to seeing with a quadratic. So you've seen this before, we've factored it, we've used a quadratic formula on this. There's lots of applications we can do in standard form. Awesome. The second one that we have is called vertex form, and this is the one that's ideal for graphing. So the second form, your vertex form, is really what we're going to be using to graph and the concept of it. The other thing I want to point out about vertex form is check this out. We've seen vertex form before with our transformations. So the last thing that we did in chapter 2, well, almost, we did those composition of functions, but then we did all that transformations of functions, the stuff we did in class. Da-da-da-da-da-da. It's going to pay off right now. Cool. Let's take a look at this thing. Okay, so in order to do those transformations and to work things over, we kind of need something that we start off at a base. So our quadratic function here, we're going to start off with just a nice little t-chart. And we're going to see if we can make any connections in any patterns. I am fine if you want to graph all of your quadratics with a t-chart, and we'll talk about that later. However, I am going to show you a shortcut, and if you like it, feel free to use that too. So it's your prerogative. Some people are partial to one versus another. And you know what? That's cool. That's the beauty of it. So let's do this thing right now. I am going to plug in just some random values here. I'm going to go with -2, -1, 0, 1, and 2. So, you always like to keep things nice and tight where it belongs. Then plug those in. If I have f of -2, so I plug a -2 into my function, what do you get? 4. Good job. If I plug in, so if I have this, f of -1 here, so plugging in a -1, you get 1. Good. Okay, what about 0? 0, 1, 1, and 2, 4. Okay, you guys are awesome. So let's graph this thing. Let's go blue. I'm going to graph my point of -2, 4. And I'm going to graph the point of -1, 1. Oopsie daisy. 0, 0, 1, 1, and 2, 4. That is what's called a parent function. So we're going to connect the dots. La, 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 la. See how well I can connect these dots on this thing. There we are, it's not too bad. This shape is commonly known as a what? Does anybody know? Yeah, a parabola. Good. So the quadratic is typically called a parabola. Awesome. All right. So, but really, you can call it a parabola. I just want to throw that out there because that terminology is used often, and I may use it, so I want to make sure that you know. If I say graph the parabola instead of graph the quadratic, you know. The big deal whenever you're talking t-chart over here is that you start with your vertex. Now, the vertex is either the minimum or the maximum point. It's the hump. Whatever the hump is, that is your vertex. And if you use the t-chart, you want your vertex to be in the middle. Then you're going to go back 2 points for the x and up 2 points for the x. And that's how you can make your t-chart. So you're welcome to do that if that's something you would like to do. Or you may use this, which I think is a shortcut. I call it the XY new Y chart. So in your homework, you're going to see pop up for instructor tips that say, make sure that you are either using the XY new Y chart or a T chart to graph for the test. Basically, the moral of the story is I do not want you using your graphing calculator to do all of this work for you. The whole purpose of learning this section is to make sure you actually know how to do it, not that you're competent to plug something into a calculator. All right, so I just wanted to clear the air on that one. Okay, so I'm going to do an XY new Y chart. With this XY new Y chart, I'm doing it in green. So I have X, Y, the A value, and new Y. So look at your X values. Remember what I said, if you're going to do a T-chart, you're going to go back and forth by 1 and 2 points. Well, if I go plus or minus 1 on the X, that means if I'm looking at this, I'm going to go back 1 and up 1. So from my vertex, if I go back, that's my negative. If I go up, that's my positive. That's where this plus or minus 1 comes from. Then, so if I either have positive 1 or negative 1, what's the Y value associated with that? Positive 1. Good. Okay, so let's look at this then. If I wanted to go back 2 or up 2, that's the next pattern that we're looking at. So I can look at this and say, okay, if I wanted to go plus or minus 2 on this, this is a quadratic. So I am squaring this. So what is 2 squared? 4. Awesome. So this green chart is your XY new Y chart. So everything that's in green right now is what you plug in. The difference here is going to be, we're going to use our A value, and this is where your transformations come in handy. Because remember, your A value is in front of the squared term. So whenever you're looking at your transformations, what's the number that's in front? It is vertical. There's, yep, stretch and shrink, good. So you can stretch and shrink. You know if A is greater than 1, then it's going to be a stretch. Good. If A is between 0 and 1, then it's going to be a shrink. Awesome. Now what if that guy is negative? Yeah, you guys totally remember this. I love it. That's when it reflects over the x-axis. That's a vertical reflection. Now for my A value for these problems, I'm going to combine my reflection and my stretching and shrinking together. They're two separate things that are happening, but whenever I combine them, I just basically take care of 2 steps in one. Yeah, so that's going to be my A value whenever I go to plug it in. Good. Okay, well, that's our basics of graphing. Now we're going to, in your next video, we're going to graph with this information in vertex form. Let's do it right now.